Electrochemistry. Electrochemistry is the branch of chemistry that studies the relationship between chemical reactions and electrical energy. It deals with the generation of electrical energy through chemical reactions and the use of electrical energy to drive chemical reactions. Electrochemistry is fundamentally based on redox, oxidation-reduction, reactions. Oxidation is the process in which a substance loses electrons, while reduction is the process in which a substance gains electrons. These two processes occur simultaneously and are responsible for the production of electrical energy. Redox reactions involve electrolytes, ions, and electrodes. Electrolytes are substances that conduct electricity when dissolved in water. Examples include sodium chloride, sulfuric acid, and hydrochloric acid. When dissolved, these substances dissociate into positively and negatively charged ions. Positively charged ions are called cations, while negatively charged ions are known as anions. The movement of these ions enables the flow of electricity through the solution. A device that converts chemical energy into electrical energy through chemical reactions is called an electrochemical cell. It consists of two main components, the anode and the cathode. Oxidation takes place at the anode, while reduction occurs at the cathode. There are two main types of electrochemical cells: galvanic, voltaic cell, electrolytic cell. In a galvanic cell, electrical energy is produced from spontaneous chemical reactions. A classic example is the Daniell cell, in which zinc and copper electrodes are immersed in their respective electrolyte solutions and connected by a salt bridge. Zinc undergoes oxidation and releases electrons. These electrons travel through an external circuit to the copper electrode, where copper ions gain the electrons through reduction. This movement of electrons generates an electric current. In contrast, an electrolytic cell uses an external source of electrical energy to drive a non-spontaneous chemical reaction. One of the pioneers in the field of electrochemistry was Michael Faraday, who made significant contributions to the development of electrolysis. He proposed two important laws known as Faraday's laws of electrolysis. Faraday's first law of electrolysis: the amount of substance deposited or liberated at an electrode during electrolysis is directly proportional to the quantity of electric charge passed through the electrolyte. Faraday's second law of electrolysis: when the same quantity of electric charge passes through different electrolytes, the masses of substances deposited at the electrodes are proportional to their equivalent weights. Electrolysis is the process of using electric current to decompose a compound into its constituent elements. For example, during the electrolysis of water, passing an electric current through water causes it to split into hydrogen and oxygen gases. Electrolysis plays a vital role in various industrial applications, such as metal refining and electroplating. Devices that convert chemical energy into electrical energy are called batteries, which are among the most important applications of electrochemistry. Batteries are classified into two types: primary batteries. These can be used only once and cannot be recharged. A dry cell is a common example. Secondary batteries. These can be recharged and used repeatedly. Examples include lead-acid batteries and lithium-ion batteries, which are widely used in automobiles, mobile phones, laptops, and electric vehicles. In recent years, fuel cells have gained considerable importance. Fuel cells generate electricity directly from fuels such as hydrogen through electrochemical reactions. They are environmentally friendly because they produce very little pollution and play a significant role in reducing emissions and promoting the use of renewable energy sources. Electrochemistry has become an integral part of modern technology. From the batteries that power our everyday devices to mobile phones, laptops, electric vehicles, and industrial processes like electroplating, electrochemistry continues to play a crucial role in technological advancement and sustainable development.